Determine the surface area by rotating the region about the x-axis. So we're looking at rotation about the x-axis. So we're interested in 2 pi y ds, where ds is going to be this guy over here. Let's go take a look at what the graph of this thing looks like before we continue. So I'm going to go to y equals. I have my cosine cube t and my sine cube t for my y. In the window, remember we are looking at between 0 to pi over 2. So I put 0 for t min, and I went to pi over 2, second pi over here divided by 2. And now I'm going to look at the graph. And it looks like the graph is this little region right here. So I'm looking at rotating this region about the x-axis. So this is my curve, and I'm rotating it about the x-axis, and it's going to generate a surface area, so the outside area of this thing that I'm looking at. I'm going to go find my dx dt and dy dt and see what happens. So dx dt is going to be, keep in mind this is cosine theta cubed, and this guy over here is actually sine theta cubed. So we're going to do 3 cosine theta and squared, of course, times the derivative of the inside, which is minus sine theta. That's going to give me minus 3 cosine square theta sine theta for my dx dt. dy dt will be 3 sine theta squared times the derivative of the inside, which is cosine theta. So I have 3 sine squared theta cosine theta. Now to find my ds, I have to square and add these guys. So let's make a correction quickly. We're dealing with thetas. This really should be dy d theta and dx d theta. I put them into here and here and square them. So we square both quantities, and it looks like they have a 9 sine square theta and cosine square theta in common. Pull those guys out, and we end up with cosine square theta plus, from here, sine square theta. We know that's just equal to 1, and so we end up with 3, and technically speaking, we end up with absolute value of sine theta cosine theta when we take its square root. But notice we're dealing with theta being between 0 and 2 pi, so between 0 and pi over 2, between 0 and pi over 2, these guys are always going to be positive. So since theta is in 0 and between 0 and pi over 2, sine of theta is always going to be positive, cosine of theta is always going to be positive. So we could just say we can look at 3 sine theta cosine theta. So I found my ds. My surface area will be from 0 to pi over 2. We have 2 pi y, and here's our ds. So we have 3 sine theta cosine theta d theta, and the bounds were given to us between 0 and pi over 2. Remember, we looked at this graph. So the graph looked something like this. It does look like it's between 0 to 1 and 0 to 1 in both the x and the y directions. However, we're dealing with it in parametric form. So the bounds that we were given here, where it says theta is between 0 and pi over 2, that's the one we are going to keep. If we were to change this into the Cartesian coordinate system and look at it in terms of x and y's, then we would use our limits of integration to be between 0 and 1. But as it is now, the curve gets traversed when theta varies from 0 to pi over 2. So everything in this integral looks okay, except I have to have everything in terms of theta. So this guy right here has to go get replaced by what y is supposed to be, which in this case is sine cubed of theta. So 2 pi y ds, I took care of the ds. Now I just have to go take care of what to replace the y with. So 0 to pi over 2, 2 pi. We said that's sine cubed theta. We still have this other business, 3 cosine theta sine theta d theta. Let's pull out the 2 pi into 3 as 6 pi outside and clean up the inside a little bit. We have sine cubed and sine, that's sine to the 4th theta, cosine theta d theta, which is a trig integral containing sines and cosines. And if you recall, we can actually do a u substitution here. Sine can be my u, since my du is sort of waiting around. So we can say u is sine theta, and du will be cosine theta d theta. And we can go back and evaluate the integral as 6 pi u to the 4th theta, and that's my du. Theta's gone. U to the 4th. Cosine theta d theta is du, and if you choose to change your limits of integration right now, you can leave the problem in terms of u and not worry about the 0 to pi over 2 anyway. So sine of 0 is 0, sine of pi over 2 is 1, and we end up with 6 pi, looks like u to the 5th over 5 from 0 to 1, which is just 6 pi times 1/5, so we get 6 pi over 5 as the surface area generated by rotating this region about the x-axis.